I'm getting pollen. I'm getting pollen. Which way out? Which way out? Which way out? Okay, thank you.
And then it gets all quiet.
Yeah, no. I'm like patting my belly and waving at the same time. Okay, everyone, good morning. How are we doing?
Fabulous. Yay, man. Yay, man.
You guys get over your disbelief and join me. Can I say yay, math?
Yeah.
All right, roll.
Oh my god.
Andrew W.
Oh my.
Okay.
Whoa.
This bee comes equipped with glasses. Here you go.
I think it's like a jetpack.
That would be awesome.
Costume comes across with.
Today we're going to be doing areas of regular shapes, regular polygons, and little composite shapes on top of it. I'm excited.
Oh my god.
Hand.
You
better
be illusion.
Evolution begins.
Illusion.
This is the bee illusion.
Yeah. The fish comes out of the water, turns to a bee, and then a human. Go figure.
I think evolution is
Darwin was wrong.
Darwin was wrong. How could this be possible?
He was always wrong.
Could it be?
It's a bee test.
Oh,
This is a bee illusion.
Alright, get up.
I'm like trying to give respect, and everyone's looking at each other like, no!
Save him up. Save him up.
All right, here we go. Please draw a hexagon.
Work out.
Hexagon.
Oh,
6
Cornelius. Orange man.
There it is.
Bye, Daddy.
All we're going to do today is talk about how to get the area of this shape.
Wow, that is an impressive.
All right, does it look like a circle?
You better believe.
Yeah.
Oh God.
So, let's talk about the wisdom behind this. All right, the wisdom behind this is that there's no real formula for the area of a hexagon. So what we can do is acknowledge that if you have trouble drawing a hexagon, draw 2 parallel lines here, and then connect like a little ruby. Right, that's the way I do it.
Oh.
That's a good method. So you got 2 parallel
Oh, I
lines,
drew an octagon.
and then
Same thing.
ruby, ruby. Okay,
They're actually completely different.
Ruby.
ruby.
Sting!
Be fabulous.
Buzz the Rooney.
Be fabulous.
Am I right?
Be fabulous.
If you look
Be, that's
closely,
what I said.
all right, save the jokes for like the right moment, not every moment.
Beep.
So, look closely at this. Do you agree that if I chose to, I could create a triangle here?
You can.
No.
Right? Assuming this shape is regular. What does regular mean, everyone?
It adds the exterior
All sides are equal.
All interior angles are equal.
All sides are equal, all interior angles are equal.
and the exterior goes out to 3/6.
That would happen if it's regular or not, but you're
Oh wow.
Interior. I
Jump.
180.
Interior adds up to 180 and minus 2,
Yes.
if you recall. So
and
that's in there.
minus 2.
That's in there.
Correct.
And we might use that later, actually. We might use
I
that.
might.
But regular means all sides the same, so let's mark that. Let's go ahead and mark all these the same.
Never being my heart.
Formula for the area.
B.
Formula for the area of a triangle is A equals 1/2
Base times height.
base times height. Very
No,
good.
I didn't hear you ask for the formula. That makes more sense.
Okay, 1/2 base times height. Now here's the question. How many of these triangles exist in a hexagon? Actually, hold it up with your hands. How many triangles exist inside?
Oh, wait.
Hold it up with your fingers. Yes. Yes. No, try again. No, try again. Yes. Yes. Yes, very good. Yes, there are. Say it together. How many? 6 triangles. So if you wanted to get the area of one, let's say the area of this one, could we also just say times 6 and we would get the area of the entire thing?
Yes.
Does that make sense?
We could indeed.
All right, rock it.
Indeedy.
Oh, here's the blue bit. So we could do that times 6. Now, let's try to get this area. Do you agree that we need the base? Suppose I gave you the base was
Base.
this whole thing, 4. Would you agree that all sides are 4?
Yes.
Okay, let's put that down. So that's given information that it's 4. And now we need the height. Let's draw the height in there. There it is. The height for a regular shape has a fancy name. Starts with an A. Does anyone know what it is? Go ahead.
Altitude.
That is true. You're right. It is an altitude. Well, altitude would be the entire thing. So I understand what you mean, especially with the 90 degrees. Go ahead. Apothem. But yeah, it's weird. It's a weird word. It's a weird word.
Possum?
It does make me think of that. It does make me think of that. But I sting them and they leave my neck of the woods
That's
as
right.
well.
Wait, when you sting them, do you die?
Yeah.
No, he's that
I'm
good.
very brave. I'm very brave. So this is the apothem. We need this. Let's talk about how to get it because it's kind of complex. Because
Hashtag
all we know is that this is 4 and that this comes down. Do you agree that if this comes down straight down that these would have to be 2 each? Can we start there? Let's start 2 and 2. All right, that's all we know, so we have a problem. What we need to get is this length. And the way to do that is to know the angles inside. Now let's talk about the angles inside. Check this out. Mr. Cornelius, smack dab. You were talking a lot about angles when I asked you questions about angle, like polygons, you would mention degrees and things like that.
Of course.
How many degrees would be in any shape all the way around starting from the center?
6. And a triangle?
No, all the way around.
360?
360, right. 360. So now let me ask you this. If there's 360 degrees all the way around, why don't we split it up into, how many triangles did you say existed here?
6.
So 360 divided by 6
360?
would be 60, that's right.
We need that.
So 60 degrees at the tops of all the triangles going around.
Well, we knew
so
that 'cause
this
they're
is 60.
triangles.
What's that?
We knew that because they're triangles.
We knew that because they're triangles, it's true. But in this case with the hexagon, all these would be 60. All these would be 60. There it is, 60 all the way around. All the way around.
Is it really only 6 triangles though? Because you could definitely split them up and make.
Correct. 6 non-overlapping triangles. You could even make more, but 6 you could say regular triangles.
Okay.
6 regular
Because it will
triangles.
make a 30, 60, 90 triangle.
It will turn into a 30, 60, 90. I was hoping you would say that, yes. So if these are all 60 degrees all the way around, we can assume this is split, and we have 30 here and 30 here, bravo. So if we have 30s on the top, and we know that this side is 2, class tell me, or maybe volunteer, the 2 is which side? The 30 side, the 60 side, or the 90 side?
30.
What do you got?
30 cents.
30 side. Were you going to say that?
30 side,
It's the
yes.
30 side. So if 2 is the 30 side, where's the 60 angle? Is it here?
Yeah.
No.
No.
No, look
No,
closely.
that's
Is
the
it here?
side, though.
Is it here? Right here.
That's the side though.
Yeah.
That's where.
That's right. That's right.
That's
You're
what I got
right.
confused about.
This is the 60 side.
Sure.
What would it be?
Sure.
2 or 3, as if it was there all along. Bravo. 2 or 3.
Ooh.
And just as a form of practice, what would the 90 side be? 4. You remember your 30, 60, 90s, right? To recap, if you know the 30 side, the side opposite 30, to get to the side opposite 60, you multiply by root 3. And to get to the side opposite 90, hypotenuse, you multiply by what? 2. Very nice. That makes this 4. Although the 4 doesn't really help us in terms of getting the height. So now we have the height, aka apothem. So let's put it down. Equals 1/2. Base is 4. Height is 2 root 3. And then times 6. This would be the entire area, but I'm not done.
Wouldn't it be 2? Oh, no.
Wouldn't it be 2?
That's right. Dun-dun-dun-dun. Pollen. Yeah. So it's okay. No, I'm glad you're looking. Yeah. The height, in this case, the apothem is 2 root 3. That went right there. The base is 4. And then we have 6 of these triangles to add up. Okay, it's going to get weird now. Any questions so far? You have to understand this before we move on. Okay.
B4.
Now there is, this is like my sidekick. There is another formula for an area of a regular shape. That's not triangles times number of triangles. And this is how it works. Do you agree that there's 6 of these bases, 6 of this base, 6 of this base, 6 of these, 6 of this? So how many bases, basically, what's the length of all the bases added up? What's the length of all the bases?
24.
24. Any questions about that? 4 plus 4 plus 4 plus 4 plus 4 plus 4. Or 4 times 6. Okay? That's the perimeter. That's the perimeter. So if you combine these two, if you combine these and make it 24, you'll get 1/2 times 24 times 2 root 3. And this is the formula for any regular shape. It's 1/2 perimeter times apothem. Please put a big box on that. That's the formula for any regular shape. The perimeter accounts for all the triangles. The perimeter accounts for all the triangles times the apothem. Some people actually like this. They're like, oh, I'll just get one triangle and multiply it by 6. You're welcome to do that. Or you can abide by the formula, which we just created together, in which the perimeter is all the triangles times the apothem. There's 6 of these. 24.
6 of E's.
6 of these. Yes, question, please ask.
Why do they have lowercase a and uppercase p?
I guess because lowercase a, just differentiate between that.
Oh, okay.
Perimeter, I guess it doesn't matter. Maybe big P because it's the entire shape. But yeah, it's a technical thing that doesn't necessarily matter. Any questions about the formula itself? Okay, let's finish out this problem and then we'll do another one. What's 1/2 times 2?
1.
1 times 24 times root 3. 24 root.
You're a little out of the camera.
It's okay. It's okay. The math is more important.
Okay.
So 24 root 3.
That's a lot.
We can say like inches squared.
No, like the math is a little bit out.
Oh, the math is?
Yeah, a little bit.
Okay. All right. 24 root 3. Put it down. 24 root 3. Yes, question. Please. Okay. All right. So we just did 1/2 times 2. We could have done this. This is 12 times 2 is 24. Any questions? Any questions on this? You feel okay? We're going to do 2 more. Okay, you ready? Okay, we have our designated eraser. Give them a buzz, please.
Wait.
Put that down. Go, enjoy. Oh my God.
Hey, Matt! That's how old bees sound.
Wait, is it a polygon or a polygon?
Polygon. Oh, Polygon. Thank you. That was good. That was good. Give it up.
That was
Give it up. Polygon. Keep going. Almost there.
Mr. B.
Is that loud enough? That hurt my ear. Hurts my hands.
All right. Thank you.
That was incredible.
Oh my God, weird. We're gonna scare the viewers. Pentagon next.
Polygon.
Polygon is good.
Came up with that.
This is good.
Yeah. Area of a regular pentagon. Let's give you the side. We'll give it at 6. What is the formula for the area of any regular shape?
Oh, area equals half
Really?
times perimeter times A.
Times A, which is for the apothem. Very nice.
Oh yeah, pop.
Okay. So now we need to go out and get each one. Do you agree that perimeter is relatively straightforward?
Yes.
Perimeter's looking right at us, right? 5 sides, each side 6. Perimeter is
30.
30. That's right. 30. So we can put that down right now.
Third bee.
30 coming down. Now we need this. Now we need this. Yes, please.
So you would do 360 divided by 3, divided by 6.
Almost. How many triangles would be in a pentagon?
5.
Let her finish. 5.
Oh, right.
So 360 divided by
5.
5. Bravo.
And whatever you get divided by 2.
To split the triangle, correct. Very nice. 360 divided by 5. What is this, anyone? Yep, got it. Calculator man.
And it's like 72.
72. Good job. So we're going to make this triangle here. This whole thing is 72. Divided by 2 now, so that's 72. Divided by 2, 36 degrees per triangle at the top. We'll put it in here. Blue, 36, 36. Any questions about how we got 36 here and here? Lovely. What would each of these bottom pieces be? What would each of these be?
3.
3 each.
What?
We're splitting the 6. Any questions you have, please voice them. Okay. Okay, and we need A. Apothem will be right here.
So would you be
Well, hold on. I know you know it. It's awesome. Any suggestions, bravo by the way, any suggestions for how we get this leg of the triangle if we know an angle and another leg? I believe 2 people know it so far. Raise your hand if you think you know it. Starts with a T.
What was the
Wait, what's the
question?
question?
What math do we use? What type of math do we use?
Oh, I know,
Three,
I know,
four,
I know.
wait.
Oh, haha.
Yeah. What type of math do we use? You're probably on it right now, actually, in which you have an angle on one side and you need the other side. Okay, the majority now knows it. Say it together.
Trigonometry.
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 Oh, God.
Trigonometry.
Trigonometry.
Alright.
That's my world. I wake up in the morning, I'm like, do the laundry, take the garbage out.
Trigonometry.
Trigonometry. Honey. Because I'm a bee.
Honeybee.
Oh, I thought
Yeah.
it was because it's a tray.
Trigonometry?
Trigonometry.
I was, and I put honey on it. It was a jar.
There you go.
I made it with my friends.
Do you call your loved ones bee instead of bay?
I
No,
call
they
him
call
Boo Bee.
honey. They say hi,
I call him
honey.
Bee Boo. I call him Boo Bee. Let's do it. What is the trig formula we can use to capture A? Is it sine, cosine, or tangent?
Divide the opposite.
Tangent of what angle?
Divide opposite by
36.
Toe.
Equals
36.
opposite over adjacent. Makes what?
3.
3 over x is correct.
My toe.
Let's go over here. Separate this a little.
Toe. T-O-H.
Okay. Cross multiply. What times what equals what times what?
36x.
Tan 36x.
Yeah.
That's right. So I'm going to put the x in the front.
Over 1. 1036.
So you can put that over 1. Some people prefer that. Let's go. X times tan 36 equals
B.
3.
3. B. Okay. Again, that's just a cross multiplication result. You know, these 2 times these 2. Or equals these 2. Okay. Isolating x by doing what to both sides?
Subtracting by tan. Or dividing by tan.
Very good. Yeah, you learned that. You learned that. Divide by tan 36. Divide by tan 36. And we're going to get our x.
Equals
In this case, I should have maybe put A. So I'm going to put A in here. Make it
A.
A for our apothem.
Should put
Okay.
B for B.
And what is the apothem? What is the apothem here? We need calculators for this. If you haven't done it already, go
I
for
got
it.
you.
Is this for the tan?
This is using tangent to solve for the apothem.
Alright.
And do you understand how we set it up?
Yeah.
Tangent of this angle?
4.129145.
4.129. So let's
Yeah.
put 4.13. Okay.
The ones after the
4.1B.
9 up. It doesn't round up.
4.129.
Yeah,
Let me see.
that's what it is.
So 4.13.
Yeah. Well,
Oh yeah, okay. Now I see.
129.
Now I see. Now I see.
We're good.
Oh god.
I will see.
Okay. Any questions about how we set it up? The setup is the most challenging part of the problem because this problem has layers. The layers are how many triangles. Divide by the number of triangles. Then divide by 2 to get these angles. Then use trig, specifically tangent. Opposite over adjacent to get that. Solve by using cross multiplication. We did all that work to get just the apothem. Any questions? Were you okay with that? You okay with? Are you comfortable with using tangent opposite over adjacent? Okay.
That's almost pi.
I'm glad. If you didn't, please let us know. All right.
4.33.
So I'm putting it down. What should I put here?
4.13.
4.13. All right. So what you could do is, if you have this whole decimal in your calculator and you haven't deleted it yet, you can just use that times 15.
Whoopsie.
And what would you get?
61.90. 62.
0.95.
Yeah.
So why don't we leave it 2 decimals?
91.
62. Okay, 61.95 or 62-ish, and we'll put if we put units of centimeters.
You should write ish next to it.
Centimeters squared. Centimeters squared. Questions? Questions on process? Really? Wow. Usually it's hard for people. Okay, one more shape. Ready?
Eraser.
Come on up. Be eraser. Be all that you can be.
It's B.
Brother.
Believe in yourself.
Believe in yourself.
Just to be yourself.
He's like, wait. Wait. Let's mess with him.
I think that's a new species of bee.
You forgot a piece, son! You forgot a little piece!
I'm not done yet.
Oh, sorry.
Wrecked. We want to hear it.
All right, move it along. You're a busy...